Hello friends, today we are going to start new chapter from section B, that is design codes used in the structural design of earthquake resistance building, in which we use IS 1893 part 1, the 5th revision in 2002. The name of the IS code is Criteria for Earthquake Resistance Design of Structures. It has 5 parts. From that 5 parts, we today we are going to see, or in your syllabus, this is only part 1 is situated. The part 1 consists of general provisions and building for earthquake resistance design of structure. This Indian Standard Code, having 5th revision, was adopted by the Bureau of Indian Standards after the draft of finalized by the Earthquake Engineering Sectional Committee had been approved by the Civil Engineering Division Council. Himalaya and Indo-Gangetic Plain, Western India, Kutch and Kathiawar regions are geologically unstable parts of the country, and some devastating earthquakes of the world have occurred there. A major part of the peninsular India has also been visited by strong earthquakes, but these were relatively few in number, occurring at much larger time intervals at any site and had considerably lesser intensity. The earthquake resistance design of structures, taking into account seismic data from studies of these Indian earthquakes, has become very essential, particularly in view of the intense construction activity all over the country. It is to serve this purpose that IS 1893 1962 recommendations for earthquake resistance design of structures was published and revised first time in 1966. As a result of additional seismic data collected in India and further knowledge and experience gained since the publication of the first revision of this standard, the sectional committee felt the need to revise the standard again, incorporating many changes, such as revision of maps showing seismic zones and epicenters, and adding a more rational approach for design of buildings and substructures of bridges. These were covered in the second revision of IS 1893 brought out in 1970. As a result of the increased use of the standard, considered amount of suggestions were received for modifying some of the provisions in the standard data, and therefore third revision of standard was brought in 1975. The changes were incorporated in the third revisions are: first change is the standard incorporated seismic zone factors previously given as multiplying factor in the second division on a more rational basis. Second change is importance factors were introduced to account for the varying degrees of importance for various structures. In the clauses for design of multi-story buildings, the coefficient of flexibility was given in the form of a curve with respect to period of buildings. The next change is a more rational formula for use to combine model shear forces, and next change is new clauses were introduced for determination of hydrodynamic pressure in elevated tanks. And last change made in revision third is clauses on concrete and masonry dams were modified taking into account their dynamic behavior during earthquakes. Simplified formula for design forces were introduced based on results of extensive studies carried out since second revision of the standard was published. The fourth revision brought out in 1984 was prepared to modify some of the provisions of standard as a result of experience gained with the use of standard. In this revision, a number of important basic modifications with respect to load factors, field values of N, that is frequency, base shear, that is V, and model analysis were introduced. A new concept of performance factor depending on the structural framing system and on the ductility of construction was incorporated. In the fifth revision, that is the revision in 2002, with a view of keep abreast with the rapid development and extensive research that has been carried out in the field of earthquake resistance design of various structures, the committee has decided to cover the provisions for different types of structures in separate parts. Hence, IS 1893 has been split into the 5 parts. That parts are: first part is general provision and buildings, in which general provisions are given for earthquake resistance design. Part 2 is only for liquid retaining walls, retaining tanks, elevated and ground supported tanks. Third part is consist of bridges and retaining walls. Part 4 of IS 1893 consists of industrial structures including stack like structures, and last part of the IS 1893 is consisting of dams and embankment. Part 1 contains provisions that are general in nature and applicable to all structures. Also, it contains provisions that are specific to buildings only. Unless stated otherwise, the provisions in Part 2 to Part 5 shall be read necessarily to conjunction with the general provision in Part 1. Some major and important modification made in the 5th revision of the IS 1893 are: first modification is the seismic zone map is revised with only 4 zones instead of 5. East file zone 1 has been merged to zone 2, hence zone 1 does not appear in the new zoning map. Zones 2, 3, 4 and 5 are shown in the new seismic zoning map. Second modification was the values of seismic zone factors have been changed. These now reflect more realistic value of effective peak ground acceleration, considering maximum considered earthquake, that is MCE, and service life of structure in each seismic zone. Third modification is response spectra are now specified for 3 types of founding strata depending on the soil strata available on the in the site. Then empirical expression for estimating the fundamental natural period, that TA, of multi-storied buildings with regular moment resisting frame has been revised. Then next modification is this revision adopts the procedure of first calculating the actual forces that may be experienced by the structure during the probable maximum earthquake if it were to remain elastic. Then the concept of response reduction due to ductile deformation or frictional energy dissipation in the cracks is brought into the code explicitly by introducing the response reduction factor in place of earlier performance factor. A lower bound is specified for the design base year of buildings based on empirical estimate of the fundamental natural period, that is TA. The soil foundation system factor is dropped in this revision. Instead, a clause is introduced to restrict the use of foundations to differential settlements in severe seismic zones. And next modification is torsional eccentricity values have been revised upwards in view of serious damage observed in buildings with irregular plans, and model combination rule in dynamic analysis of building has been revised. Other clauses have been readapted where necessary for more effective implementation. The IS Code 1893 revision 5th consists or cover first in one is specific seismic design force, seismic requirements of for design detailing and